The warm-up today says to find the asymptotes. Anyone remember how to find these? It's been a while. We usually do vertical asymptotes first. How do you do vertical asymptotes? Yeah, what makes the denominator equal to 0? So set the bottom equal to 0, see what you get. Well, that's factorable, right? X minus 1, x plus 1. So what's the solution? Plus or minus 1. Good. So that's where our vertical asymptotes will be. What about horizontal asymptotes? Those are the trickier ones. You look at the degree of the numerator compared to the degree of the denominator. Which one has a larger degree right now? The denominator. So where should we have one? Y equals 0. But we have a minus 4 on the end, which means that our whole graph is going to go down 4 units. So where is our asymptote? Negative 4. Very good. That's what we did before break. You guys took a quiz over it. Overall, the quizzes were pretty good. So this is something that you do have somewhere in your memory. Hopefully you will have a test over it next week. Homework check next week. Lesson, work day this week. Any questions on what's to come? All right, here's our information for today. We're doing section 9.4. It's all about multiplying and dividing rational expressions. Rational expressions is a fancy way to say what? Rational numbers are what? Fractions. So we're multiplying and dividing fractions today. So if you can remember what you know from your grade school days about multiplying and dividing fractions, that will all apply to what we're doing today. Just a little more complex. All right. Here's a little bit more information about what we're doing today. So a rational expression, like we were just talking about, is a fancy way to say a fraction. So a fraction whose numerator and denominator are non-zero polynomials. If you feel like that's something you want in your notes, go ahead and write it down. If not, just take it in as information. All right, so as I was saying, if you want to write the definitions down, great. If it's something that you feel you already know, don't waste your time on it. We already talked about the first one. Rational expression is basically a fancy way to say a fraction. Simplified rational expression, when the numerator and the denominator have no common factors. So basically, we're going to factor the top and the bottom. We're going to simplify them. Any questions before we get going? Now, most of this lesson is on multiplying and dividing, but at first we're just going to practice how to simplify these. Then we're going to get into the multiplication and division. Do you guys know how to factor the numerator of this rational expression? It's a difference of squares. So what do we do?
Y plus 9, y minus 9.
Exactly, y plus 9 and y minus 9. So I'm going to rewrite the top in its factored form. Now I can factor the bottom. Anyone know how to factor the bottom?
2 plus 9.
Yeah, you just factor out a 2. So 2y, 2 times y minus 9. Just divide both of them by 2, write the 2 in the front. Now, what term or what factor do you see in the top and the bottom? The y minus 9. So the y minus 9s are going to cancel. That leaves you with a y plus 9 in the top and a 2 in the bottom. If you can handle this example, you are going to be in good shape today. I gave you some time. I know some people are writing the information on the top. Let me know if you come up with a question. Here's example 2. So again, the strategy here is to factor the numerator, factor the denominator, and then see if any of your factors will cancel out. Can we do anything with the numerator? No. Can you do anything with the denominator? take a 2 out, right? So we're going to rewrite this as 2 times, and then you divide everything by 2. So 2x minus 3. You can see 2x minus 3 and 2x minus 3 are in the top and the bottom, so I'm going to cancel those out. What am I left with in the numerator? Just a 1 and then a 2 in the denominator. So 1/2 is our answer on this one. Questions? All right, here's number 3. Is there anything we can do in the numerator? No. Anything we can do in the denominator? Yeah, it's multiply add, so multiplies to 9, adds to 3. Or sorry, adds to 6. Just gave it away. Yeah, it's 3 and 3, so we have x plus 3 and x plus 3. Bless you. Now, how can we simplify this? Yeah, an x plus 3 in the top and the bottom. Do not take both of your x plus 3's away from the denominator. Okay, a lot of people, they just want to cancel all the x plus 3's. If you have 1 in the top and 1 in the bottom, those cancel. Okay, you can't cancel 2 things from your denominator with 1 thing in the numerator. It doesn't work like that. All right, what's left in our numerator? A 1. All right, and then we have an x plus 3 in our denominator. So 1 over x plus 3.
I thought he was about to say there's actually a real from even coming.
Yeah. Any questions on number 3? All right, we'll keep moving along. How can I simplify the numerator? Take a y out. That would leave us with y times y minus 7. The bottom's MA, so multiplies to 7, adds to negative 8. Negative 1 and what?
7 and 1.
Both negative, right? So y minus 7, y minus 1. So the numerator and the denominator have what in common? Y minus 7, so I'm going to cross them out. In the top I have a y, in the bottom I have a y minus 1. Now, I am sure none of you would try to now simplify these y's. Okay, good. You guys should be beyond that. That's what my freshmen like to do. So don't fall into old habits if that's something you used to do. Remember, the only thing that simplifies are factors, not terms. That's what it says right here. So just make sure that it's a whole, it's a whole factor, like the x minus 7, and not just a term, like the y's. Okay? Questions on this? All right, now we're getting into the actual multiplication part of our lesson. The cool thing is it's very similar to what we were just doing. You guys know from your multiplying fractions days, when you multiply fractions, you just multiply the numerators, you multiply the denominators, and then you simplify. Or some teachers call it taking out the trash, I think, where you simplify as you go. We're going to simplify as we go. So I'm going to start by factoring everything that I can factor. So that trinomial in the first numerator is going to factor to x plus 3, x minus 1. So I'm just going to rewrite that. The denominator in that expression is not going to simplify, just x plus 2. However, the other numerator will. I can pull an x out. And then that's the difference of squares. So I have factored everything I can possibly factor. Now's the fun part. So anything that you see in either numerator can cancel with anything from either denominator. What do you see that's going to cancel? Yeah, the x minus 1s. And the x plus 2s. I think that might be it. So, you need to figure out what you have left. So we have an x plus 3 and we have an x. And then we have an x plus 1 in the denominator. Now, I'm okay if you leave it like this. Some people don't like to leave their answers in factored form. If you want to distribute the x, it's not going to change anything. Some students find themselves going in circles here, so just once everything has been simplified, you can leave it like this. What are your questions on this one? All right, here's number 6. We're going to do the same strategy, so we're going to factor everything that we can, and then just start crossing out. First numerator, what can you do? Take out a 5. So that's going to be 5, and then in parentheses we'll have an x minus 4. What else? We can go with the denominator. Take out a 5. Oh, or you can do the next numerator. Take out a 2. This factoring's all GCF, so it's pretty easy. Yeah, you take a 5 out of the numerator, and then the denominator, and then our last denominator just stays x minus 4. So it doesn't really matter what order you factor it, just factor everything that you can factor. This is my favorite part. What can I get rid of? The x minus 4s, the 5s, and the x plus 3s. Good. So we're actually only left with 2. What are your questions? All right, here's number 7. This one's kind of tricky. Can you factor anything? No, you can't really factor. So the next step would be to try to see what is going to cancel. Now, do you see how this is almost the exact same thing as this? What are they off by? A negative sign. So here's the trick. If you factor out a negative 1, now they would be the exact same. So I'm going to factor out a negative 1. That turns my 12 into a negative and my x into a positive. And again, normally we wouldn't do that, but we saw that it could cancel if we had the sign straight, so that's kind of the trick there. So now you can go ahead and cross them out. Get rid of those 3's as well. What's my answer? Negative 1. Good. So if you're off by just a sign, you can't say, oh, whatever, I'll cancel it anyway. But you can manipulate it to make it work in your favor. Any questions? All right. I'm going to give you a second to write this one down because something very fun is going to happen. Mm-hmm. All right, what happens when you divide fractions? Do you guys remember this from years and years and years ago when you were doing it by hand?
Don't you flip the second?
You flip the second one, you change it to what? Multiplication. Same thing here. I'm going to rewrite the problem as a multiplication problem. I'm going to flip the second fraction. Now it's the same old process. These are all monomials. None of them will factor, so you can just get right into the fun part. Start canceling. The 48 and the 36 are both divisible by 12. So that's how I get 4 and 3. I have some x's. X squared over x just leaves you with an x in your numerator. And I think that's it, right? The y's are both in the denominators now, so they're not going to cancel. So in the top I have 4x times 5, that's 20x. In the bottom I have y times 3 times y squared. You can just put all your y's together and you get 3y to the third. So same process, you just flip and multiply. Any questions? All right, here's number 9. How can I start this? Flip it and change it to multiplication. So I'm going to flip the second rational expression. I'm going to change the division symbol to a multiplication symbol. Same old process. There's only one thing that's going to factor, so I'm going to go ahead and do it. That's a difference of squares in our first denominator. So I'm going to write it as x minus 1, x plus 1. And then you can start simplifying. So x squared over x just leaves us with an x. X plus 1 over x plus 1. Those go away. So right now I have x over this 3 right here times this x minus 1. Sometimes when you're crossing stuff out, you'll miss something. You'll think it's crossed out, but it's not. This one kind of blends in. So just be careful when you're going through that last step that you're checking pretty closely. What are your questions on this? Alright, here's your homework. I told you guys this already, but it's written on the board just in case you were tuning me out earlier. Originally tomorrow was supposed to be a work day. I think this lesson's fairly simple. I don't think you really need a work day after a 5-day weekend and then a lesson that's fairly easy. So tomorrow will not be a work day as stated on your schedule, but you will get one this week and it will be on Friday. Any questions?